Jarrett Lardy, who will be presenting methods to reduce runoff, erosion, and increase plant establishment for pipeline restoration. Jarrett, feel free to share your screen when you have a chance.
Thank you, Brady. Does this look right?
Everything, switch back to the other screen you were just at, Jarrett.
Okay. Better?
Perfect, you're good to go.
All righty. Well, thank you for the introduction. As Brady said, my name is Jarrett Lardy, and I'm a master's student in soil science here at NDSU. Today, I'll be presenting my research from Western North Dakota on seed preparation methods to reduce runoff, erosion, and increase plant establishment for pipeline right-of-way restoration. In the US, nearly 2/3 of all energy consumption stems from oil and natural gas. North Dakotans know this very well, as the western part of our state has been in an oil boom since roughly 2006, with fracking making oil from the Bakken and Three Forks formations much more accessible. Since 2012, North Dakota has been the second largest domestic oil producing state, only behind Texas. In North Dakota, natural gas is synonymous with oil production, as natural gas is often found within our oil reserves. Previously, operators had to flare natural gas as the infrastructure or pipelines had just not been constructed yet to transport this natural gas. As of the third quarter of 2020, the North Dakota Pipeline Authority reported that 92% of natural gas in North Dakota was captured, which actually exceeded the state's target goal. In North Dakota, there's an enormous amount of infrastructure to go along with these well pads. Each well pad typically has a pipeline to transport not just natural gas, but also brine water and oil. In the map, you can see that the activity centers around the Bakken and Three Forks formations, with Wofford City and Williston being at the heart of all this. In North Dakota, there are over 29,000 miles of pipelines just for natural gas. When a pipeline is constructed, it is an extremely invasive process, as the right-of-way is first stripped of its topsoil, and then a trench is dug for the pipe to then be laid in, with the soil being replaced on top of it, and then the entire right-of-way being reseeded. These right-of-ways are typically 75 to 125 feet wide, running the entire length of the pipeline. In North Dakota, for the natural gas pipelines, there are roughly 400 square miles of disturbed soils, which is the equivalent of 4 Theodore Roosevelt National Parks. As you can imagine, it is extremely hard to return some of these right-of-ways to a productive state. Some of these companies often face many challenges, which are including but not limited to compaction from the heavy machinery that builds these pipelines, as well as erosion when plants fail to establish, and also invasive species when those plants fail to establish as well. When these invasive species move in, pipeline scars can often form. You can see pipeline scars from aerial imagery, much like the picture shown, and the pipeline scars are often monocultures of smooth brome, Kentucky bluegrass, and cheatgrass. Smooth brome and Kentucky bluegrass are extremely common in North Dakota and highly invasive. When none of these plants take root within the right-of-way, these pipeline companies need to come in and reseed the right-of-way, sometimes coming in 3 or 4 times to reseed. That often costs a large amount of money, and these companies need to get that plant establishment done, as that's the key to reclamation, to avoid further erosion and encroachment of invasive species. That led us to come up with several objectives for our research, as we wanted to know if there was a seed preparation method which was optimal for reducing runoff and erosion, as well as if there was a method which aids plant establishment. There are a number of different methods that reclamation uses. The ones we decided to test are imprinting, hydromulching, and straw crimping, with imprinting being one of the more novel ones that we tested. Imprinting is typically used in arid regions. However, North Dakota is a semi-arid region. The imprinter that we used has V-shaped funnels, which bring that soil, seed, and water and keep it within the right-of-way as it brings it to the bottom of those imprints. Those imprints are typically 3.5 inches deep and about the size of a piece of paper. When that water and seed collect within each imprint, it creates a microclimate, which is designed to improve that germination success. We also tested the use of hydromulch. Hydromulch is an extremely effective method to improving plant establishment. Plant establishment needs that seed and water, and the hydromulcher allows that seed and water to be distributed across the right-of-way at an even rate, as you can mix that seed within the hydromulcher. It also creates a seal when it uses that wood fiber hydromulch, as it limits evaporation within the right-of-way, especially during the hot summer months that North Dakota sees. That seal also holds together sediment from the right-of-way, limiting erosion during heavy rainfall events. This method does have one major con though, as it has a huge water demand. For our plots, we had a 24-foot by 380-foot plot, and that used over 1,000 gallons of water to impose this hydromulch. We also tested straw crimping. Straw crimping is very common in North Dakota, as North Dakota has vast amount of barley and wheat residue each year due to wheat and barley production. Straw crimping uses a bale buster to spread a bale across the right-of-way and then followed up with a disc to crimp that straw into the right-of-way so that it faces up, kind of mimicking barley residue. That straw then has a path for water to infiltrate and reduce that runoff as it brings it into the soil surface. Lastly, we tested the combination of imprinting with hydromulch. We knew that that hydromulch would have that seal effect, increasing that runoff. And so we thought the combination of imprinting with hydromulch might allow some of that water to infiltrate a little better than their individual counterparts. For our control, we tested a bare ground control and tilled it up just as a right-of-way might look if it did not have any treatment imposed on it. Our study took place in Williston, North Dakota, which is semi-arid, as we said, and they normally see 13 inches of rain each year. However, they're in an extreme drought and only got 4.5 inches of rain in 2020 and 7.5 in 2021. We used a strip plot design using 3 blocks for our study, with each strip testing the effects of slope, testing 2% slopes on the top and 5% on the bottom. We then broadcast seeded everything, including the hydromulch treatments. We did not put the seed within the hydromulcher. We broadcasted oats, side oats grama, green needlegrass, slender wheatgrass, and western wheatgrass. To analyze our runoff and erosion, we applied several rainfall simulations. We applied 50 gallons of water to 3-foot by 6-foot plots for 30 minutes. This simulated a 1 in 25 year rain event. And these rain simulations were conducted in September 2020 and June of 2021 to showcase how those treatments behave over time. Each rainfall simulation for September was in a D2 drought, and then in 2021 was in a D3 drought. Those droughts are ranked by the U.S. Drought Monitor on a 0 to 4 scale, with a D2 drought being a severe drought and a D3 drought being an extreme drought. Here's a short video of our rainfall simulator. We had a trough at the bottom of our plot to collect that runoff and bring it into a bucket for analysis. And looking at how our rainfall simulations behaved, we noticed for runoff, we had a year effect due to those drought conditions, as well as a treatment effect. For our sediment load, we had a treatment effect as expected. Looking at plant establishment, we combined our desired species with weedy species that moved in simply because we had poor germination for our desired species. For the bare, you can see that it was 50.8% cover with the other 49.2 would have been that bare ground. As you can see, there's no treatment effect for our plant establishment, as well as no treatment effect for our slopes. Splitting our runoff up over time, we looked at hydromulching produced over 30 liters of water, which is about 8 gallons of water. And then we also noticed that our imprinting treatments produce significantly lower results than our mulch and imprint with mulch treatments. One imprint rainfall simulation did produce 0 liters of runoff. As time went on, we noticed that the straw treatment was the only one to be statistically different than our control, as that was bringing in that water into the soil surface using the path of that straw. We also noticed that these imprints settled out over time, bringing that runoff value up, allowing for less water to be incorporated within the soil surface. Looking at our sediment load, we noticed that the mulch and imprint with mulch treatments had very low values. The bare treatment was statistically similar to everything except the ones including mulch. And this led us to several conclusions. We noticed that the imprinter worked very well over time. As you can see from our photos, in 2020, those imprints filled up very well. And then in 2021, they were almost non-existent. For long-term right-of-way protection, the best treatment was our straw treatment, as it brought in that water and reduced runoff overall. We also noticed that the imprint with hydromulch was not different than the mulch treatments, and we do not recommend it for that reason because it would be much more expensive to use. Our recommendations are to use the straw on right-of-ways as it is the most economical treatment. In times of drought, though, it is necessary to get whatever cover you can. The water is key to plant establishment, and that plant establishment is key to our reclamation process. You need water to get these plants to survive. With that, I'd like to thank several of our sponsors, specifically One Oak and the North Dakota Water Resource Research Institute, as well as the Williston REC for hosting us. And lastly, H2 Enterprises and Chris Martin for helping us set up these treatments. Thank you.
Thank you, Jarrett. So far, we don't have any questions coming in. If anybody in the audience does have one, feel free to shout it out now.
Can I ask a question?
Absolutely.
Okay, Jarrett, can you talk more about the seed mix that you use in your experiment?
Yeah, the seed mix was a mix from the North Dakota State Trust Lands. We incorporated oats within that to hold our treatments together over the fall, as our plant establishment wasn't going to be analyzed until August of the following year. So we needed something to hold everything together. So we picked oats, as that would die back the following year. And then those grasses were native, and that's what's typically used in a lot of seed mixes for right-of-ways.
Great, thanks.
All right, thank you, Jarrett. With that,